Hi, I'm Vineet Mohan, the project leader of VSMTRS, that is Vehicular Speed Monitoring and Traffic Routing System. A wireless sensor network is a sophisticated system which finds its use in applications like ocean and wildlife monitoring, military surveillance, etc. The same concept of large-scale monitoring and surveillance through wireless sensor networks can be implemented to ensure enhanced safety measures and innovative traffic controlling techniques. The proposed vehicle speed monitoring and traffic routing system utilizes wireless sensor networks wherein a sensor node is installed in all automobiles which can communicate among themselves and with a central monitoring station, along with the sensor nodes placed at appropriate points on the roads.
This figure shows the various applications of wireless sensor network that our proposed system intends. The modes installed in vehicles will act as nodes in the network and help in sending or receiving data to or from the central monitoring station. This can be used to control traffic effectively, report cases of overspeeding directly to police, and immediately inform medical departments in case of accidents and reduce the risk of road accidents. Overspeeding of vehicles can be easily detected at the CMS, and the driver can be alerted and the same can be reported to the police station. By this way, the drivers can be aware that they are being watched by police and overspeeding can be prevented to a large extent. The modes can warn the nearby vehicles about the speeding vehicle and the distance of the speeding vehicle from the other vehicles. Again, the risk of road accidents is greatly reduced. Even in cases of accidents, alarming system can be implemented and medical facilities can be made available at the earliest by informing hospital as well as police station for necessary actions. At position A in this figure, there is a chance of traffic jam as there are more number of vehicles at that position. The CMS can identify this situation by knowing the increase in the mode density at that position. Thus, the CMS can inform the other vehicles about the situation at position A with the required details like the street at which this situation prevails so that they can choose a different path and hence reduce the chances of traffic jam. Suppose the vehicles are going to petrol pump via route A, the other vehicles can also choose route B with the information from the CMS.
The system is built up of wireless modules including Crossbow MP4 2400CA. It is a Mika-Z mode. And this is the main module, the smallest unit of a wireless sensor network, which is used for sending and receiving data. It has a 51-pin connector which is used to interface it with the DAC, that is the data acquisition card. And it uses ZigBee protocol for wireless transmission. It has a 2.4 gigahertz processor, that is Atmel processor. And this is basically a mode. This costs around 10,125 Indian rupees. We have 3 such modes in our position, and plus one mode is used as a gateway. When a mode is loaded over a programming board, it acts as a gateway. We'll come to that later. Now the next thing that we have here is the data acquisition card, which is also called DAC, and this is E24460. This is also from Crossbow. This is called MDA320. This is the product ID of this data acquisition card. It also has the female pin or the female connector, 51-pin connector. And this thing is the most expensive component of this whole system, and it costs around 20,000 rupees. We have only one DAC with us. And this is the programming board. It is also the USB to PC interfacing board. This is used for 2 purposes. The first one being the programming. Any NSC code can be programmed onto the mode. You can see the mode being loaded over the programming board. This can be simply connected with the 51-pin connector. Just placing it over it will do the job. This thing costs around 9,000 rupees, and we also have only one programming board with us right now due to the limitation of the budget. And this also acts as a gateway, as I said earlier. When a mode is loaded on to the programming board, it acts as a gateway because it is connected to the server also. And this mode has to be particularly programmed as a base station mode so that it could accept all the broadcasting information and can send it to the server. Also, the other modules that are included is a microcontroller and a motor, which is not shown here. The softwares used are TinyOS, Crossbow MoteWorks, which include XSniffer, MoteView, MoteConfig, MATLAB 7.3 for data processing, and PIC16F877A is used for generating required data. MPLAB assembler is used for microcontroller programming. This is a system or a small scenario wherein we are trying to showcase the traffic routing module. As you can see, we are having 3 modes here, and the 4th mode is kept over the programming board, which acts as the base station. Now, this mode is kept separately as an external checkpoint, and these two act as if they are installed in 2 separate cars. Now, due to the limited number of modes that we have set the preset limit for traffic jam as 2 cars. That means whenever 2 cars come close to the external checkpoint simultaneously, the 2 cars will send the packets to the external checkpoint, and the external checkpoint will be able to detect the number of cars in its proximity by calculating the number of different mode IDs that have sent the packets to this external checkpoint, and whenever this exceeds the preset limit, which is 2 in this case, it will send a package to the base station. The base station will carry forward this message to the server, which will display it on the central monitoring station. Now, as you can see, these 2 modes are right now in the switched off state. When I switch it on, this LED blinks here. Similarly, here is another mode. Right now I have switched on only one mode, and hence only this mode is sending packets to the external checkpoint. Since the number of different mode IDs that this external checkpoint is receiving is only 1, and it is not exceeded the preset limit, the checkpoint will not send any packets to the base station. Now I am going to switch on the second mode. Now it signifies that 2 different cars have arrived at the external checkpoint's proximity, and therefore both of these 2 cars are sending the packets to the base station, to the external checkpoint. Now the preset limit that is set as 2 in this case has been exceeded, and therefore the external checkpoint will send a packet to the base station, and hence the signal or the message that the traffic jam has occurred and hence take an alternative route will be displayed on the central monitoring station. This system here is actually a DAC, that is a data acquisition card loaded with a mode. The mode can be connected to the data acquisition card using the 51 pin connector. As you can see, there is another 51 pin female connector on the DAC, and the 2 can be coupled so that the mode is connected with the DAC. Now the main purpose of the DAC is to act as a connector, because as you can see, the pins of the mode are very small. The 51 pin connector is very small, and it is very difficult to manually connect the 51 pin connector or the mode with the external world. Therefore we use the DAC, and as you can see, the DAC has different pins with different purposes, like VCC, that is a voltage supply, ground, and this last pin is the interrupt pin. Now the interrupt pin is connected to a an overspeed detection mechanism. When the car overspeeds, an interrupt is generated by the overspeed detection mechanism and is fed to the mode through this interrupt pin. The mode is programmed in such a way that when it receives an interrupt, it detects the overspeeding of the vehicle and it sends a package to the base station. This is the base station. The base station receives the packet and sends this information to the server through the USB interface. And the server can be a laptop or any computing device. The server then uses this mode ID. Every mode has a unique mode ID, and the server can use the mode ID to map it with the car's registration number, and this can be utilized to send a fine to the offender's home or office.